हेलो एवरीवन, वेलकम टू इंजीनियर्स करियर पॉइंट। इंजीनियर्स करियर पॉइंट चंडीगढ़ में सेक्टर 34 में लोकेटेड है। इंजीनियर्स करियर पॉइंट में हम जून 1 से फुल ऑफलाइन एंड ऑनलाइन गेट बैच स्टार्ट कर रहे हैं। इन दिस वीडियो वी आर गोइंग टू स्टार्ट 50 important टॉपिक्स फॉर गेट एग्जामिनेशन फ्रॉम द सब्जेक्ट पावर सिस्टम। हमने हर सब्जेक्ट का, हर इंजीनियरिंग ब्रांच का 50 important टॉपिक्स फॉर गेट एग्जामिनेशन हमने स्टार्ट किया है। ये 50 important वाला सीरीज में we will discuss the very important and the tough topic of GATE examination of that respective subject. Suppose अगर हम पावर सिस्टम लिया तो पावर सिस्टम में बहुत सारे टॉपिक्स हैं, उसमें 50 टफ टॉपिक्स हम लेंगे, हम पढ़ाएंगे और उसके बाद उसके ऊपर क्वेश्चंस भी सॉल्व करेंगे। सो चलो चलते हैं पावर सिस्टम सब्जेक्ट पे। पावर सिस्टम सब्जेक्ट पे वेरी इंपॉर्टेंट, स्टार्टिंग में वेरी इंपॉर्टेंट थिंग वी हैव टू लर्न before we start with power system subject is power transfer equations of transmission line as well as synchronous machine। पूरा पावर सिस्टम तीन चीज के ऊपर चलता है, एक सिंक्रोनस मशीन, सिंक्रोनस जनरेटर, दूसरा ट्रांसफार्मर, तीसरा ट्रांसमिशन लाइन। ये तीनों के ऊपर हमको अटमोस्ट नॉलेज होनी चाहिए। तो हम ये वाला वीडियो में क्या कर रहे हैं, वी आर गोइंग टू डिराइव द power transfer equations of synchronous machine and transmission line. In fact both are similar, we are going to derive, हम derive करने वाले हैं। इसमें दो तरीके के इक्वेशंस होते हैं, एक एग्जैक्ट इक्वेशन है, दूसरा अप्रोक्सीमेट इक्वेशन है। क्या क्या अप्रोक्सीमेशन है, वो अप्रोक्सीमेशन वैलिड है कि नहीं, ठीक है। ऑल दोस थिंग्स वी आर गोइंग टू टेक अप इन दिस वीडियो। चलो चलते हैं। और सब्जेक्ट इज पावर सिस्टम। यस, सब्जेक्ट इज पावर सिस्टम। यस, आपको पता ही है power system for electrical engineers is one of the very important subject है power system, right? And इसका weightage GATE examination में 12 to sometimes up to 20 marks they will ask. 12 minimum of 12 marks you get, 10 to sometimes, see that depends on the paper, but minimum of 10 marks will be asked and average is of 12. Sometimes maximum it go up to 20 marks also. Power system, right? Power system, see power system, as you know, the topics are like this, important topics for GATE examination. Broadly I am saying first one is transmission. Sir, first generation आता है ना, तो generation का weightage बहुत कम है। Why? Because generation is completely theory. That's why last priority I give for generation. Transmission, उसके बाद I can say analysis part. What is that analysis? Fault analysis, उसके बाद yes, stability analysis, उसके बाद load flow studies। इसके ऊपर ये टॉपिक्स, 4 टॉपिक्स है ना, ये टॉपिक्स के ऊपर पक्का क्वेश्चंस आएगा, कम से कम एक टॉपिक से 2 क्वेश्चंस आएगा, ठीक है। उसके बाद इंपॉर्टेंट टॉपिक्स होगा, यस, the 5th topic is power system protection, उसके बाद होगा I can say economic load dispatch, EAT, economic load dispatch, Lagrange multiplier, fuel factor, okay, cost functions, those things are economic load dispatch। उसके बाद important होगा power generation, concepts of power generation। The last topic है yes, distribution। ये सब गेट सिलेबस में है, लेकिन ये 4 टॉपिक मिला के आपको 1 या 2 क्वेश्चन आएगा तो आएगा, नहीं तो नहीं। Sometimes in paper from these 4 topics no question will be asked, but these days they are asking on ELD and power system protection. Therefore from these 4 topics, from those 4 topics you may expect 2 questions, not more than 2 questions। But यहाँ पे जो topics हैं first priority topics है, ये these topics are of first priority। पक्का 2 क्वेश्चन, ट्रांसमिशन से 2, फॉल्ट से 2, स्टेबिलिटी से 2, लोड फ्लो से 1। I won't say from load flow you get 2 questions, 1 question will be definitely will get। So these are the topics in the entire power system syllabus, right? Now आज के वीडियो में हम क्या करने वाला है, we are going to derive the power transfer equations of transmission line। which are very important. Total transmission, synchronous motion equations are also similar. In the end I will give how those are similar, that also I will give you. Okay, electrical equivalent circuit, if we draw, then we get the similarity, right? यहाँ पे आ जाइए. Our heading is power transfer equations of transmission line. Power transfer equations of transmission line is our topic. Of transmission line. ठीक है? तो पावर को आप जानते हैं, ये पावर is comprised of two parts. One is real power and reactive power, or active power and reactive power. Real power is also called as active power, right? So we know that S is equal to P plus JQ. S is equal, basic formulas very important, P plus JQ, where P is real power in megawatts and Q is reactive power in megawatts, and S is called as apparent power and the units are MVA, and that is equal to voltage into current conjugate. Voltage into current conjugate. Without conjugate, the sign of reactive power is going to be different. That's why definitely we have to take V into I conjugate, right? So this is general power formula from network analysis. Now I am talking about what? Transmission line. See, I am taking one transmission line. Yes, this is a transmission line. Yes, every transmission line is going to have two ends. One is sending end and one is receiving end. So this is sending end, this is receiving end. So I call this one as a sending end. I am not writing full length that one, just I am writing it as S dot E, sending end, and this is a receiving end R dot E, right? Sending end and receiving end. At sending end side, yes, I'll assume the voltage as Vs. At the receiving end side, I'll assume the voltage as VR. And you know that we connect load at the receiving end side. Yes, here the load is connected. Now some current is flowing from sending end side. Yes, some current is going to flow from sending end side, IS. In fact, all these are phasors. Okay, and some current is going to be there at the receiving end side. By looking at this transmission line, you may say, sir, IS is equal to IR. No, this is single line diagram representation of a transmission line. Actually, transmission line is going to have shunt capacitance, shunt conductance, series resistance, and series I can say reactance. So this transmission line is going to have four components in the electrical equivalent circuit: series resistance, series inductive reactance, shunt capacitance, and shunt conductance. These four are the elements we represent in the electrical equivalent circuit of a transmission line. Therefore, IS is not equal to IR unless it is a short transmission line. Okay, unless it is a short transmission line. We are taking it as just a transmission line. You know that every transmission line is going to have ABCD parameters. We represent transmission line with help of ABCD parameters. Yes, observe here carefully. Observe here carefully. So I'll take like this. These are the ABCD parameters of the transmission line. So very ABCD parameters are very important. So the name itself, those are parameters. Those are going to depend on the configuration of the transmission line, right? So sending end and receiving end. We know very clearly that at sending end side, the power, I call it as power injection, I call it as SS, that is equal to PS plus JQS. SS is equal to PS plus JQS. At receiving end side, the power that is received, I call it as SR, that is equal to PR plus JQR. आपके दिमाग में बहुत सारा क्वेश्चंस चलते होंगे कि सर ये एसएस कौन दिया है, कहाँ से आया, ये एसआर कहाँ से आया. देखिए सेंडिंग एंड पे if you assume a generator, synchronous generator, that is the one which is injecting power into the sending end bus, and that power is traveling from sending end towards receiving end, and load is receiving that power. But in this there are two powers, active power and reactive power, so we have to discuss about those things, right? I want power transfer equations at the sending end side and receiving end side. So आपको ये लगता होगा सर क्या है, वोल्टेज और करंट है ना, तो VS into IS conjugate लगाओ आ जाएगा. Yes, but my aim here is to find the power transfer equations of the transmission line in terms of ABCD parameters. Yes, I want to find the power transfer equations of the transmission line in terms of ABCD parameters, right? Now we all know, see, first let me take at the receiving end side, then I come for sending end side. Okay, sir, you may be thinking, sir, why you are not taking first at the sending end side, why at the receiving end side? Because at the receiving end side my load is sitting. Once we understand that, then sending end is going to be very easy for us. We can make some conclusions. In fact, first you do sending end, then receiving end also, you can make the same conclusions, but it is always convenient in student point of view to do at the receiving end side. Okay, yeah, observe here. But one thing all of you must remember in your mind is, that is power, someone has to give, someone has to take. Power is law of conservation of power. It is similar to law of conservation of energy. See, suppose 500 watts of power is there, in that 200 someone is taking, remain 300 someone has to take, if 500 is the supply, or something must be lost, but never power is going to remain like that, or never that mismatch is going to happen, right? Yeah, see, my heading is at the receiving end side. The first one, at the receiving end side. At the receiving end side. Yeah, at the receiving end side, what is the formula? Yes, SR is equal to VR into IR conjugate. VR into IR conjugate. See, all of you, one thing must remember, that as load changes, current will change, but the change in the voltage is going to be very small. Yeah, we have to design our power system network that way. The change in voltage should be less, because if current is increasing, the change in voltage is huge, or the reduction in voltage is huge, then loads will not satisfy. So we have to design our power system network in such a way that the change in voltage is less, or almost we are going to take Vs and Vr as constants irrespective of the load. Yes. Now I want my power equation in terms of voltages and ABCD parameters, but not in terms of currents, So I want to replace this current with something. For that I am taking some equations. Please all of you observe these equations, right? Yeah. So these equations are Vs is equal to AVR plus BIR, right? Yeah. Sending end voltage is a function of receiving end voltage and receiving end current, right? We all know this one. Now IS is equal to, yes, CVR plus DIR. So these ABCD are the parameters. So from this one, I am going to get BIR is equal to Vs minus AVR. So from this one, IR is equal to Vs minus AVR by B. Vs minus AVR by B. That is the current IR, right? Now, see, every voltage, we are in AC analysis. Yes, we are talking about AC power, not DC power. We are in AC analysis. So every voltage, current and ABCD parameters are going to have two things. One is magnitude, another one is angle. Every alternating quantity is going to have magnitude and angle. Now let's write those. Magnitude and angle. See, I am taking here A as mod A at an angle of alpha, and I am taking B as mod B at an angle of beta. I am taking C as mod C at an angle of gamma. I am taking D as mod D at an angle of triangle delta, right? Triangle delta. And I am taking Vs, sending end voltage Vs as Vs is equal to mod Vs at an angle of this delta, the Greek delta, right? And Vr as is equal to mod Vr at an angle of 0 degrees. Here you will get a doubt. So how do you know that receiving end voltage angle is 0? We are taking that one as a reference. Yeah, there are two quantities. Suppose 100 and 50. You can do one thing, you make the 100 as 50 and 50 as 0. See, I'll tell you like this here. Observe. Here, 10 at an angle of 60 is there. Here, 10 at an angle of 30 is there, right? This is sending end voltage angle delta S, sending end delta S is 60, delta R, receiving end voltage angle delta R is 30. That difference is 30 degrees. What I do is, I write this one as 30, I write this one as 0. I write this one as 30, I write that one as 0, right? 30 and 0, clear? So this angle minus that angle, and I take that one as reference always, right? I take that one as reference always. Observe here carefully. Observe here carefully, this all of you. Yes. So observe here carefully. Yeah. So VR is equal to mod VR at an angle of 0. Now come on. SS is equal to VS mod VS at an angle of delta, into IR conjugate. From this I want IR. IR is what? VS minus AVR by B. Yes, IR is SS is equal to mod VS at an angle of delta, that is, yes, what is that? VS minus AVR by B. VS minus AVR by B. VS minus AVR by B. Right? Now, SS is equal to mod VS at an angle of delta. Conjugate we have to take, I forgot to take the conjugate. We have to take the conjugate here. Into VS. Mod VS at an angle of delta, therefore it will be minus delta. A will be mod A at an angle of alpha, so it will be minus alpha, into mod VR at an angle of 0 degrees by mod B at an angle of minus beta. But because B is mod B at an angle beta only, but if you take the conjugate, it is going to become its opposite sign. See, positive angle will become negative, negative angle is going to become positive angle, right? Let me write in the next page, that is SS is equal to, so we are not at the SS, so we started with the receiving end side, right? SR, no, see some SR we want, so here not SS, actually I am deriving the sending inside the equations, we are in the receiving side inside equations. Let me erase this one. We have to find first receiving end equation. Our heading is receiving end, not sending inside, please. Yeah. What we did is correct, but that is of sending end. Later we will be doing after this one. Okay. What we did is exactly perfect and it is correct, but I did for sending end. Our heading is receiving end. So SR is equal to VR. What is VR? Mod VR at an angle of 0 into IR conjugate. What is IR? Yes, VS minus AVR by B. VS mod VS at an angle delta, AVR mod A at an angle of alpha, yes, VR mod VR at an angle of 0 degrees by mod B at an angle of beta whole conjugate. So SR is equal to mod VR at an angle of 0 into mod VS at an angle of minus delta minus mod A mod VR at an angle of minus alpha by mod B at an angle of minus beta. Right? Mod VS at an angle minus delta minus mod A mod VR at an angle of minus alpha by mod B at an angle of minus beta. Right? Now let's derive the remaining part. SR is equal to, so VR mod VS mod VR, yes, mod VR at an angle of minus delta, by mod B at an angle of minus beta. When it comes to upside, it will become plus beta. Beta minus delta minus, yes, mod A mod VR square by mod B at an angle of beta minus alpha, and it is in MVA. Well, you know what is MVA? Right? Yes, megavolt amperes. Now from power triangle, what is power triangle? S is equal to P plus JQ. If you draw its triangle, yes, this is P, this is Q, this is phase angle phi. If I take, now tell me, cos phi, you are going to get cos phi is nothing but P by, this is S, P by S, that implies P is equal to S cos phi. P is equal to S cos phi. What is sin phi? Sin phi is equal to what? Q by S. Q is equal to S sin phi. S sin phi, right? So S equation we have. From that I want to get P as well as Q. From that I want to get P as well as Q. Let's write down. Let's write down P and Q equation. So PR is equal to mod Vs mod Vr by mod B cos of beta minus delta minus mod A by mod B mod Vr square cos of beta minus alpha. This is the exact equation of real power. Yes, this is the exact equation of the real power, and its units are in megawatts, and its units are in megawatts, right? So mod Vs mod Vr by mod B cos of beta minus delta minus mod A by mod B mod Vr square cos of beta minus alpha, right? Megawatts, that is exact power equation. Now exact real power equation. So I want QR. QR is equal to mod Vs mod Vr by mod B sine of beta minus delta minus mod A by mod B mod Vr square sine of beta minus alpha. Yes, MVARS. MVARS. So this is the reactive power equation. This is what? Reactive power equation, right? These two are the exact equations. I know that it is very difficult to remember the exact equations, but if you remember the procedure how I solved and we have the basics, within no time, within 1 minute you can derive these equations. I suggest you not to mug these equations. If you understand and remember, yes, it is very good, but if you forget, the fundamental is you can, with the fundamentals you can derive these equations, right? These are the exact equations. These are the exact equations. Then what are the approximate equations? Please look at those equations. Mod Vs mod Vr by mod B cos of beta minus delta mod A by mod B mod Vr square cos of beta minus alpha, right? Yeah. If you, in place of cos, if you put sine, those are going to be, that is going to be a reactive power equation. Now observe here, please, all of you. Now here the point is approximate equations. Approximate equations. Approximate equations. What are the approximations we are taking? What are the approximations we are taking? The very first approximation is transmission line is assumed as short transmission line. What's that? Short transmission line with zero resistance. With zero resistance. With zero series resistance. Now, what are the ABCD parameters of short transmission line? ABCD is equal to 1 Z0 1, that is equal to 1 Z is, yes, R plus JX, this is 0, this is 1, and the resistance is neglected. So the ABCD parameters are 1 JX01, 1 JX01. Yes, let me write here, that is the ABCD parameters of short transmission line are, yes, A, B, C, D parameters of short transmission line are, what are those one? 1 JX0 1. If you write in the form of A at an angle alpha and all, 1 at an angle 0, this is X at an angle 90, and this is 0 at an angle 0, and this is 1 at an angle 0, right? So these are the ABCD parameters of transmission line with approximation. We taken the given transmission line as short transmission line with yes, with the resistance neglected, Now substitute those in our PR and QR equations. What is PR? PR is equal to mod Vs, yes, mod Vr by mod B. Parameter B is nothing but X. Parameter B is nothing but X. X into cos of beta. What is beta? Alpha, beta, gamma, delta, triangle delta. Beta is 90 minus delta minus mod A is 1 by mod B is x, mod VR square cos of beta 90 minus alpha 0 degrees, that is cos 90. Cos 90 is going to be 0, then PR is equal to mod Vs mod VR by x into cos 90 minus delta is sin delta, right? Cos 90 minus delta is sin delta, that is in megawatts, that is in megawatts. So mod Vs mod VR by x into sin delta megawatts. This is the equation which is going to govern our entire power system. Yes, entire power system, we are going to deal with this equation. We are going to deal with this equation, entire power system, right? So mod Vs mod VR by x into sin delta. So after this, we have to get reactive power equation, QR. So QR equation, yes, I suggest you remember this QR equation because lots of questions on QR equation, lots of questions you can find in previous GATE. So how to get QR equation? QR is equal to, yes, QR is equal to, yeah, mod Vs, yes, mod Vs mod VR by mod B into sine of beta is 90 minus delta minus mod A by mod B mod VR square, yes, sine of beta 90 minus alpha is 0 degrees, alpha is 0 degrees. So QR is equal to mod Vs mod VR by x into sine 90 minus delta will be cos delta minus mod VR square by x. So if I take mod VR by x common, then you are going to have mod Vs cos delta minus mod VR. Yes, mod Vs cos delta minus mod VR. So I'm putting that in bracket. QR is equal to mod VR by x into mod Vs cos delta minus mod VR. This is MVARS. Because see, later something I'm going to derive, not derivation, in fact I can say some conclusions I'm going to take up, that is how much is sending in reactive power, how much is receiving in reactive power, what about the difference of the reactive power, who is consuming, who is giving. A lot of things are going to happen. This is very, very important. So see, these approximate equations I suggest you to remember. See, as you are at the receiving end side, mod VR by x, yes, mod Vs cos delta minus mod VR, mod Vs cos delta minus mod VR. Remember this. We are done with the receiving end side exact and approximate equations, and after this we have to go with the sending end exact and approximate equations. Sending end side. My heading here is sending end side. Yes, sending end side equations. Yes, second one is sending end side. Sending end side. As you got expertise in the receiving end side, sending end, I'll cover fastly. What is that? SS is equal to Vs into Is conjugate. I told you we do not want current term in the power equation. I want to replace current in terms of ABCD parameters and voltages. So what are the equations I have? Vs is equal to AVR plus BIR. So Is is equal to CVR plus DIR. Now if I write this one in the form of matrix, so Vs Is is equal to A, B, C, D and VR IR, that is VR IR, yes, VR IR is equal to ABCD whole inverse, ABCD whole inverse into Vs Is, right? So VR IR is equal to ABCD whole inverse is, yes, ABCD whole inverse is 1 by AD minus BC. This is D, this is A, this is B, this is minus C, minus B minus C, this is Vs Is, right? You know that for a practical transmission line, A equal to D and AD minus BC is equal to 1. For a practically realizable transmission line, A must be equal to D and AD minus BC is equal to 1. Therefore, what we got, VR IR is equal to, yes, we get it as a D minus B minus CA. This is going to be Vs and Is. Let's write the equation of VR. From this one, let's write the equation of VR. if I write the equation of VR is equal to dVs minus BIS. From this one, BIS is equal to dVs minus VR, right? So IS is equal to dVs minus VR by B. dVs minus VR by B. So from this one I get IS is equal to mod D triangular delta mod Vs at an angle of Greek delta minus mod VR at an angle of 0 degrees by mod B at an angle of beta, right? But I want IS conjugate. Let's find the conjugate here itself. So IS conjugate is equal to mod D by mod B mod Vs at an angle of delta plus delta. Conjugate, it is minus beta. When it comes to upside, it will become plus delta. Yes, observe carefully. Is conjugate, no, this is going to become minus. I wrote wrong, let me write it clearly. Okay, if you take the conjugate, this is going to become minus, this is going to become minus, this is also minus, but this downside one is coming to upside, it will become plus. So you are going to get beta minus delta, right? Minus delta minus mod VR by mod B. When you take conjugate, it will be minus beta downside. When it comes to upside, it will be plus beta. It will be plus beta, right? Is is equal to clear. Is is equal to clear. Now Is conjugate, in fact. Now SS is equal to Vs mod Vs at an angle of delta into Is mod D by mod B mod Vs at an angle of beta minus, just a minute, beta minus delta minus mod VR by mod B at an angle of beta, right? At an angle of beta, right? So SS is equal to mod Vs square into mod D by mod B at an angle of the delta will get cancelled, beta minus delta minus mod Vs mod VR by mod B at an angle of delta plus beta, at an angle of delta plus beta. Clear? Now from this one I get PS. So PS is equal to mod D by mod B mod Vs square cos of beta minus delta minus mod Vs mod VR by mod B cos of beta plus delta, right? Megawatts. Now QS is equal to mod D by mod B mod Vs square sine of beta minus delta minus mod Vs mod VR by mod B sine of beta plus delta MVARS. These are the exact equations. I won't suggest you to remember these equations, but I suggest to remember the approximate equations. What are the approximate equations? Are same approximations. What are those? A is 1 at an angle 0, B is x at an angle 90, C is 0 at an angle 0, D is 1 at an angle 0, right? Substitute those. So you are going to get PS is equal to D is 1 by x mod Vs square cos of beta is 90, delta is 0 minus mod Vs mod VR by mod B is x cos of 90 plus delta. If you observe, this one will be 0 because cos 90 is 0. So PS is equal to minus cos 90 plus theta. Cos 90 plus theta is minus sin theta. Minus of minus is plus. That is mod Vs mod VR by x into sin delta. Yes. Observe here carefully. So PS equation is equal to mod Vs mod VR by x into sin delta. If you remember carefully, this is nothing but a PR equation. So why PS and PR equations are same? Why? Because we take in resistance is equal to 0. If there is no resistance, there is no power loss. If power loss, active power loss, I'm talking about active power loss, P. If there is no active power loss, see, X is related with the reactive power, R is related with the real power. R is equal to 0 we taken, there is no one to consume that real power. Therefore, sending end PS is equal to receiving end PR. Yes, approximate power transfer equation of real power at the sending end side and receiving end side, both are same. Now let's go for QR. Let's go for QR. Now I'm writing QR here. So approximate QR equation. QR is equal to 1 by x into mod Vs square, sorry, not Vs square, mod Vs square. Mod Vs square into cos of beta minus 90. So not cos, sin, it should be sin. It should be sin. Sorry, it should be sin, not cos, because we are in QS equation. Sin of 90 minus 0 degrees minus mod Vs mod Vr by x into sin of 90 plus delta. Now from this one, if I write, yes, QR is equal to sin 90 will be 1. I'll take mod Vs by x outside. Then you have mod Vs minus mod Vr sin 90 plus delta. Second quadrant positive only. Therefore, it is cos delta. If you observe carefully, sorry, this is not QR, please. This is QS. I wrote wrong. This is not QR. This is QS. Sending inside, please. Sending inside. QS. Right? So observe it carefully. The QR equation is mod Vr by x, mod Vs cos delta minus mod Vr. QS equation is mod Vs by x, mod Vs minus mod Vr cos delta. Cos delta is shifted from here to there. See, the best way to remember. But QR is not equal to QS. Why? Because x is not equal to 0. Transmission line series reactance, that is parameter B, we did not take it as 0. Therefore, that result, the difference amount of reactive power is going to be there in the transmission line. It is going to consume that reactive power transmission line, right? So these are the approximate and exact real and reactive power equations, yes, of a transmission line. I told you how these are similar to synchronous machine power transfer equations. Let me discuss that also. For a synchronous machine, yes, the internally induced EMF, we take it as mod E at an angle of delta, and synchronous machine is going to have resistance and some reactance because of armature reaction and leakage. Those things we consider, and we get this. I call this one as resistance and this one as reactance XS. Okay, and this voltage is terminal voltage mod we are at an angle of 0. Only thing is this is Vs actually in the transmission line mod Vs, but it is becoming E here. That's all. And there are R and X. There the ABCD parameters you can find for this one. The equations are going to be similar. Just you have to replace the respective things. In place of Vs, you substitute E. And this is not VR. We take it as terminal voltage. We take it as terminal voltage V. So we take it as terminal voltage. So here P inside P generation is equal to, see, suppose if you take this resistance is equal to 0, if you take this resistance RS is equal to 0, say mod EV by X into sin delta, you get PRPS. So the power that is generated here, the power that is delivered here, both are equal, real power, both are going to be equal. Power PG is equal to P terminal, that is equal to mod E mod V by X into sin delta. In the same way, QG and QT, you'll get the both. The difference is going to be this excess reactive power, right? So see, very simple. This one, if you want, I can make like this. If you want, I can make like this. This is ZS, I call ZS. Instead of ZS, R plus JXS, R plus JXS. R, if I'm talking about the approximate equations. If I talk about the approximate equation, resistance is neglected, then its ABCD parameters are going to be 1 at an angle 0, XS at an angle of 90, and 0 at an angle 0, and D is 1 at an angle 0, right? And this is mod A at an angle of delta. This is mod V, not VR, please. Mod V at an angle of 0, and this current is IS, and this current is IR. So this power is SS, and this power is SR. We are going to get all these things very clearly, same as that of the previous. So this is about these equations. Master these equations master these equations. One question I have here is, sir, we are taking voltages and currents. Those are line voltages or phase voltages? If you take line voltages, the obtained power PR, QR are three-phase powers. If you are taking phase voltages, that PR, QR are going to be, I can say that PR, QR are going to be single-phase powers, right? If you take line voltages, VS, VR are line voltages, then PS, PR, QS, QR are three-phase powers. If we are taking VS, VR as phase voltages, then PS, PR, QS, QR are phase powers, per phase powers, right? So Our Engineers Career Point is located at Sector 34A in Chandigarh. You can come for walk-in, and we are going to start a new batch for offline and online, full-fledged new batch for offline as well as online from 1st of June. Thank you.